All right, so here's another corollary. So corollary 3 says any spanning set can be shrunk to a basis. So in the previous corollary we said, okay, we can add. So in the previous corollary we said we could add a vector, right? So we could have a we could add a vector to a set under certain circumstances and till we get a basis, right? So here it says any spanning set can be shrunk to a basis. And so here's the proof. So we're going to call the spanning set S. And so if a couple of things get out of the way. One is if S is empty, then it's already a basis and we're done. Okay? If S contains the zero vector, then it can be shrunk to the empty basis and thereby making it independent without changing the span. Okay? And thereby it's, finding a basis. Otherwise, S contains a vector S1 that's not the zero vector. And what we can do is we can form a basis B1 with that vector. Okay? Now, if B1 is equal to the span of S, then we're done. Right? But if not, then we can let B2, hold on a second. If not, then there's a vector S2 in the span of S such that S2 is in the span of B1. Or excuse me, I'm sorry. Not in the span. That's what we want. Not in the span. Okay? So again, let me say that again. Okay, so here's where, let's go back to this here. So, if we can form a, let's see here. So, otherwise, S contains a vector S1 that's not equal to 0, and we can form a basis B1, which just contains S1. And then again, if the span of B1 is equal to the span of S, then we're finished. Otherwise, if the spans are not equal, then there's another vector S2 that's in the span of S such that it's not in the span of B. Okay? So then what we're going to do is we're going to form another sequence, right? B2 equal to S1 and S2, the two vectors. Okay, so now we got another basis, right? B2. Now, by the previous lemma that we've talked about, we know that this is linearly independent. Okay, so again, if the span of B2 is equal to the span of S, we're done. Okay, otherwise, we can keep repeating the process until the spans are equal, and we know that this can only happen a finite number of times. And that finishes the proof.